G'day guys, this is basically part 2 of that cooked and burnt out detector. It's working, as you can hear. I've probably got the threshold a little bit on the high up, but it's very hard to grab the controls because the knobs aren't there. But I was turning the amp up, and maybe that's how it sounds. I haven't used one of these for a while, but there we go, that'll probably do it. I'm going to take it out of deep mode and put it in normal, just so you can hear it. Make sure you can hear it. That's what it sounds like. So what we're going to do with this, I was going to show you some stuff. Now, I replaced those two MOSFETs for 2SK1334s, and that is running a lot better. I fixed up where it was burnt on the other side of all that black stuff, and she's going all right. Now what I was doing, if I can find my test stick, see, a lot of people don't realise this is not a bad detector, and I'll explain why it's not a bad detector. It's in the workshop at the moment. It's in cancel mode on a small coil. I've just ground balanced it to some dirty Denali dirt. So it's ground balance. Ground balance is perfect on really hot ground. But even though it's just got normal timings, we can do things about that. And as I look, we'll just use old 0.05 on it. Right, do you think it would pick it up, 0.05? You know, oh, it's old technology, you know. Here we go. That's in cancel mode. That's going really, really well. You would find good gold with that detector. There is nothing wrong with these old detectors. Okay, let's really push the limits here. Right, so we'll get something a bit smaller. Okay, this thing here. Oh, that's a 0.055. That's not really small, but you know. Different shaped bit of gold, get a different response. But can we get down? Can we pick up that 0.025, or is it really asking for too much? I don't know. It's pretty small. No, I think we're asking for too much. But there's let me have a look at where I've got this thing. I'm going to put it in deep, and if you look at all the switches here with their funny markings, I'm going to put it fixed. That's normal. That's interesting. I didn't realise I had it on normal. It gets confusing. Normal is not sensitive on this detector. They keep changing the way they name them. I just took it out of sensitive, and with that 0.025, we're actually hitting the coil. It does register it's there. It'd be better distance underneath. The coil windings are on the bottom of the coil, not on the top of the coil. But I need the hot ground. I mean, we can twist it over. I have got this thick cable protector because it gives a more gentle bend radius to the coil. You can have a look. It's just cable tidy. and that stops you bending your coil cable on the same point all the time, and it ends up breaking the cable wires inside. It just starts snapping the strands. So because this is on and off, on and off, on and off, this has been redone, and it actually has that big cable protector, and that just stops it bending all the time on one point. It just spreads out the way it works. Anyway, we've got this little tiny bit of speck in there, that thing. We'll see if it works. It knows it's there, but it's not a clear signal. You wouldn't dig that out in the ground. There's no way known you would. Oops, fat fingers. You wouldn't dig that out in the ground. But now what's the biggest one we got here in this collection? Okay, 0.1. Same as the thing. Be mindful, this is in cancel mode. I can't run normal timings in here, it'll just go completely nuts. So that's a GP Extreme normal. That is definitely, I can't even push the switch. Oh Jesus, there we go. That's in this sensitive mode. And I'll give you an idea of what this thing sounds like too. If you put it in its shallow mode, you listen to this. Would you ever use it? I wouldn't use it. It's got that warble to it, but I just use my 0.05 on it. It's picking it up much the same as that other 0.05. My one's probably not as good because just different shaped gold's going to give a different response. So, but you know, if you want to start picking up 0.1s and that. Like I say, all I've done is just swapped a couple of transistors on it. We can alter the actual timings. We can put variable gain in it. We can put variable timings in it. We can do all sorts of things on this. And by doing that, you get a bit more of a versatile detector. Yeah. So that's that thing. Old dirty, burnt out resurrection. So, yeah. Oh, I'm going to show you something too, by the way. I'm going to turn this off. I'm going to show you these capacitors. Now, I'm pushing the switch like it's a GPX because I'm just don't see a lot of these. Okay, it's disconnected, right? She's disconnected, no power. It's sitting there. Now watch this. I'm going to have to get this really close so you can probably hear it and see it. Well, what I'll do the 15 volt capacitor first. You might be able to see it even sparkles. Just see how we go. This one here. There we go, in the middle of the screen. So I'm just doing this all by hand. It's hard. Oh, there it goes. Whoa. You see the sparks? Okay, if you short anything around here with that charged, it'll blow up componentry. You don't want to have that capacitor charged. It's got the other one down here, the other 15er. Whoops, there we go. I'm looking at the board and holding the phone. It's very difficult, but that one there's usually nothing in it. It's only the negative 15 here, right where those points of the thing are, there. But the dangerous one is Mr. Bitey here. That's the one with 185 volts on it, or thereabouts. So let's see what happens if I do this. Okay, get right in. Bang. See that? Went off with a bang. So, whoa, there we go. Bang again. Okay. Be careful. Didn't discharge on the first short. Okay. It's now shorted out and it's dead. Right? So it managed to crack twice like that. That is 185 volts. It will really cause you a freaking serious freaking sore arm, or you know, if you got two hands on it, be very careful. It might even kill you. Be careful. That's the pointy little bits sitting there in the middle of the screen. On all the detectors, they will bite you. Pulse induction detectors will bite you. Okay, so just be very, very careful. Okay. Yeah, I think Chara just came in and I heard some ruffling behind me. I don't know if it was got a delivery or something. Don't know what she did. Oh, hang on. I know what she did. I'm looking over here, and right in the middle of the screen there, right there was a tub of crispy corn. So she's grabbed the crispy corn. Had to grab something. Yeah, so that's that. Anyway, that's the an old, very old GP Extreme. And if you probably noticed too, they ground balance beautifully on that stuff. Not a problem, doesn't care less. So this can we can extract a lot more gain out of this. We can clock up the frequency or even lower it, depending what you want to do. You can do a lot of things with this old detector, modify it up, and it'll be really good out in the goldfields, and it's probably just as good as just about anything else out there. Unless you want the tiny VLF fly specs, you know, then you get a VLF detector and pick up very shallow fly specs all day. But for decent sized gold, you know, one of these will do fine. You know, if you've got variable gain on it, which these come out with not, they don't have it. So you can't tame it to the ground that you're operating, but we can put variable gain in it with our variable gain board, and yeah, you can go work anything. Not a problem. That's what we do with the GPXs anyway. Oh, basically any of the older Minelabs and the GPXs. Just the new ones, they've encapsulated, you know, Minelab, bless their little black hearts, have encapsulated all their front end input stages now, and a lot of control wires and things. And I think it's got active gain and stuff like that in it. But anyway, because it's made of some sort of plasticky resin, you can't get into it. You can't do anything. You can't do any modifications. So that's probably why there's going to be new detectors coming out, because you know, people love modifying their detectors. It's no good if you seal it all up and make it unmodifiable. You know, what's the fun of that? It's no fun anymore. Dear me. So yeah, but we're still modifying. We've actually got a 6,000, 7,000 getting dropped off shortly for full upgrades. And actually I think Dave's got a stack of detectors coming in, and I've got to pull my finger out and get all this done. As you can see behind me, there is detectors all over the place. So yeah, there's always detectors on the floor here, so I don't let people come in because I'll stand on them. So yeah, well, I've been shipping them out, getting them in, shipping them out, and trying to keep up with it all. I'm working really late into the evenings now. I don't get out of here until probably 10 or 11 o'clock, which is, you know, really putting in some hours doing these detectors. But, you know, what's a new detector worth now? You know, if you buy a new GPX, I've been told they've all gone up in price. So what is it? It's a 6,000 is somewhere, must be just a smidge around $10,000. My God, you know, $10,000. What's the 7,000? It's probably over $10,000. I don't know. Just my opinion from what people have told me. I could go look it up, but that's damn expensive. And you've got to use special coils with, chips in them and stuff, and you're going to get, well, there's no more $50 coils on the second-hand market, is there? It's all, you're going to change your coil size, you're going to pay for your nose. I still don't know why. Maybe those coils, I'll say maybe, that the coil's got some magic in it, and it has to look at the ground, and it has to work out the inductance and the capacitance or any variations in the coil, and it has to alter itself to suit the conditions of the ground and the characteristics of the detector, maybe the impedance, maybe cable capacitance, maybe, I don't know, I'm just guessing, but I think it's only got one data line back, a serial data or something, it just tells it to detect the coils there. But yeah, I have my own opinions of why those chips are in the coils. I could say all sorts of things about that, but I might be wrong, mightn't I? But then again, I might be right. But like I say, it's just my opinion, because I don't know. I didn't design it. Anyway, because of all that, these older detectors, with the older coils and everything, there's plenty of them around. And, yeah, I wasn't going to mention that other thing, but, there's things kicking around that use older coils, which are a newer modern machine. So in that regard, this is just my opinion, of course. It's just my opinion that, the door has been left wide open, and the door is allowing things through. And, yeah. But, yeah, I have my own opinions on things and my own assumptions. And like I say, I don't really know. I always say that I don't really know, because I'm only guessing. It's just an opinion. It's just is it an informed opinion or a formed opinion? One or the other. Anyway, enough crapping on about that. But yeah, these older detectors, you can see them round, and you can get one cheap. I don't know what you get one of these for now. You probably just $1,500, $1,800. I don't know. What are they worth? But the thing is, you can do a lot with it. It's very flexible, because you can get in and modify it. You can do things. You can put a whole stack of new 2004 parts in it, not going back to, the 1990s old parts. The componentry has really changed a lot. There's newer processors. It's just better all around. I mean, and by the way, before I said about the input FETs, not the BSP 121s swap with the 2SK 1334s, but I said the ROHM, Rome, what they call themselves. I think it's a Taiwanese company. I think I've been using them for years, actually. But I just order stuff. I don't really pay any attention to the company, but they got some good stuff. When I said I was using the 2N2007's BK version, there's two types. There's a normal version got phased out. It's a BK. That's what I was talking about. I just remembered I said I was talking about this detector. These use P, and that 2N2007 thing I mentioned with the BK after it, which means it's the new version. Yeah, that's an N channel, so don't put that in there. It won't work. It will work. It'll be as deaf as a post, because it'll be counter switching. Right? It'll be turned off and expectancy signal. You'll just get capacitive leakage through it, or basically you'll get conductivity through the diode junction in the wrong channel FET. So you get a diode drop. It'll still work, but it'll be absolutely horrible. So you want to use the new P channel FETs, and if you want to use a really good P channel FET in these for the secondary FET I think I've got them here somewhere. Yeah, I don't know. Put them somewhere. I put them where I wouldn't muddle them up with something else. What's over there? No. Hang on. I keep getting lots and lots of new parts in there. That's timers. Yeah, I did have it before. So I should mention what it is because it's a really good part. What's that there? Oh, dig deep. What do we got? Here we go. Found the things. Okay, these are what you want. These are from Mouser. So you can have a look at that. I'll read it out anyway. If you really want to know what it is, it's a RSC 002P 03T 316. What a mouthful. But anyway, it's a 30 volt, 250 milliamp SOT device, and it's P channel. But the specs on this, if you want to look it up, it's a really good device. And this would be better, this one here, if I actually flick those ones on the other side of the board out and put these in there. But, you know, like I say, be careful doing these detectors. For some reason, the laminations on the boards on some of these detectors are very, in my opinion, very prone to come off very easy. Okay, so just be wary of that. But yeah, those there, and get rid of, well, like I say, I got rid of the BSP 121s and I stuck in those 2SK 1334s. I actually have better devices than the 2SK 1334s, but I got them in a limited batch because I actually wanted them made for myself, and they are a vertical DMOS channel FET, which are very, very low noise. I specifically got them done for low noise, so this doesn't need that amount of low noise capability. Especially, it's just doesn't. It's not running special little sharp timings, and I haven't got super low noise amplification stuff done like that in it. It's going to basically stay as it is. But yeah, I got thousands of 2SK 1334s. I knew when Renesas was going to, or Hitachi Renesas, the American-y Japanese company. I don't know where it actually, who runs it and what it is, but Hitachi did make these devices, and then it was Renesas made these devices, the 2SK 1334s. Then they stopped making them. They put out a bulletin saying we're not going to make any more, and so I bought 4,000 of them. I thought that would last me quite a while, so I've got a lot of 2SK 1334s, and should last a fair while. But like I say, I've got some better ones, but I only got about 100 made, and I really want to keep them for real special jobs and my own detectors, right? So, but it does give a little bit of a benefit. You know, you want to keep the resistance out of the front end. You want to keep the you know, the MOSFETs stable when they're in conduction. You don't want them gibbering around. You don't want any gate modulation. You don't want anything like that happening. It just stuffs up your signal coming in. You know, you can measure all that sort of stuff and refine, and yeah, and the power supplies in these things need a bit of touching up as well, especially if the caps get old and start drying out. You've got to remember, a lot of electrolytic capacitors only have a service lifetime. Some of them are only some of them, cheap ones, are only 3,000 hours, right? So if you use it every day for years and years, well, if you calculate it out 8 hours into a day into 3,000 hours, it'll tell you how long you can expect the caps to last. And you know, really expensive good caps, you know, nice low ESR ones are very expensive, and some of those last, all rated to 15,000 hours. And because these ones are all painted in white paint, I don't know what they are. If you scrape it back, it takes the paint off the capacitor, off the plastic, so you don't know what's in there. I suppose you can take them out and measure them. I've got a capacitance checker. I can check them, check their ESR and their actual capacitance. But yeah, that. Anyway, because this is at the end of this video and no one's going to be here watching it, I'm doing another giveaway. Right? We're giving away the gold down there, but I am giving away a whole stack of uncut opal, if you can see it there. So yeah, there's some reds, crystals, and blues, greens. They're all just rock. There's a really nice red one there. It's probably going to, possibly someone can cut that, turn up really nice. But I'm going to do a proper video on that anyway. I'm just giving you a peek. That's going to be a subscriber giveaway as well. So maybe a fair whack of dollars worth of opal there. But the thing is, you know, I'm not going to do anything with it. So anyone who wants it worldwide, I don't care. Just when it comes up, you know, whatever I do to give it away, you can possibly get it. Yeah, so yeah, it's nice opal actually. Anyway, that's probably enough waffle. I'm waffling. It's terrible when you make videos and things pop into your head and you go, oh yeah, you know. So I better hit the button before I think of something else. Anyway, catches.